Hello all, this is Vijayendra Gaikwad and today we are going to see how to implement MapReduce in MongoDB. So to start with, let us try to understand what exactly MapReduce is. So as you can see, MapReduce is a general data processing method, but it accepts large volumes of data as input and tries to reduce that data into some useful aggregated results. So, talking in terms of MongoDB, we have collections and we have huge, a large number of documents present in every collection. So, whenever we have to extract information from those collections, we will use the find method, or generally we use the find method whenever we have to extract the information from the collection. But with the find method, the problem is we can only search or extract that information or that data which is directly present in the documents of those collections. But there is whole lot of information which is indirectly present in the collection, and we don't have any other way but to use some aggregate methods or aggregate functions to extract that additional information. So one of the aggregate methods to extract the information from the collections is to use the MapReduce method. So MapReduce operates in two ways or in two phases. Number one is the mapper function. So what the mapper function does in case of MongoDB, it accepts all the documents from a given collection and then emits the specific key value pairs. Now how to do that we'll see in a while. After the mapper function has emitted the required key value pairs, there is a reduction function or a reduce function. Obviously, it is also a user defined reduce function which accepts the key value pairs which were emitted by the mapper function. Then it tries to reduce the accepted key value pairs into some smaller aggregated results. Generally, whenever we have a specific key and value pair which is sent from the mapper function, there is a possibility that for the same key there will be more than one values. So in that case, when the mapper function emits the key value pairs, the multiple values that we have for a specific key, those values will be kept or will be stored as an array for that particular key. So as a value for that key, we will have a array of uh, values which are having the that specific key. So in order to go ahead, this is the basic syntax of using the MapReduce function in MongoDB. So whenever we have to perform any aggregation function with the help of MapReduce function, we will use db dot collection name dot MapReduce, and then you can use the MongoDB shell in order to execute this function. For the MapReduce function, we have three parameters in general. Number one is the the mapping function. Second one is the reduce function, and third is the document which accepts two fields. Number one is the query field, number two is the out field. Now what are these two? So suppose we want to perform the MapReduce operation on some specific documents from our collection. So the the criteria which we want to apply on the given collection of documents, that criteria is specified in the query field. So if I want, for example, if I have a students collection and I have to perform the map reduce operation on the computer branch students only, there I will specify the field's name, that means branch, and the name of the actual branch, that is computer engineering. So whatever map reduce operation we are going to perform, that will be performed only on the documents which are having branch field as computer. Okay, so this is a kind of filter that we are applying before we start the map reduce operation. The second argument, or the second attribute to the third parameter of the map reduce function, is the out field. Now what the out field is, whatever is the output of the map reduce function, definitely that output will also be certain set of documents. So that documents, or those documents, will be stored in a collection with a name whatever you have specified as the out field. So in short, a collection will be created with this name, and whatever is the output document from the MapReduce function, those will get stored in the resultant document, or sorry, the resultant collection. So for seeing an example, I have a query over here, that is, we will have to find year wise total number of students from the computer branch. So to have a look at what data we are going to deal with, if so, here we have a collection called test, and we have inserted a few documents in this test collection. The document obviously contains the ID field, the name field, roll number field, class field, and branch field. So likewise, I have a few documents for the same collection. Here, class specifies the year in which this student is studying. For example, this is T, so it specifies, it represents third year, and branch is obviously computer. This is third year, and branch is IT, so on and so forth. So, what our query demands is we have to find year-wise total number of students from the computer branch. So, firstly, our map function will be something like this. So what we have done, we have simply created a variable to store the mapping function. We have named that variable as mapfunc. The function, as I discussed earlier, it is going to emit a key value pair. Now what we have to emit, that is given as arguments. I mean, the key is the first argument to the emit function, and the value for that key that we want to send to the reduce function, that is the second argument to the emit function. Now here we have specified this dot class that says send the class as key from the current document that is given by this. From the current document, send the class as key and 1 as the value. Now what exactly is the meaning of this one? We can pass any other field from the current document as value for this particular key. But what our query is demanding, we have to calculate the total number of students year wise, right? So if I have a class third year, then definitely I'll have a count 1. Again, if I have another document in which class is third year, then I'll have to pass a 1, because we are in the reduce function. What we are intending to do is we are going to accept an array of ones. We are going to accept an array of ones for a single year. So as we discussed, if there are more than one values for the same key, then an array of those values will be accepted by the reduce function. So here we are saying that for the second year, we are passing an array of ones. Whenever the class will be second year, it will send a 1. Similarly, whenever the class will be third year, it will send a 1. Similarly, when the class will be final year or BE, it will send a 1. So this is the mapping function. Going ahead, we have the reduce function. So as I told, it will accept a single key, and for that key, whatever values we have got from the emit function, we will be creating an array of those values. So if there is a unique single value for a specific key, then definitely it will have a single value. Next, we will have the return statement in our reduce function. So what it is going to do, it is simply going to sum up the values, or the values which we have in this array, right? So our array name is values, and we are summing up those values present in this array. So for that we are using array.sum method, and we are specifying the name of the array, which in our case is values itself. So as a result, what we will have, for a given key that is passed from the mapping function, we will have a corresponding sum of values, and that is what we want. If we have a second year class, we want the total number of students from that class, right? Okay, so these were the two map and reduce functions. Ultimately, we have to mention these two functions in the map reduce method. So we have to execute the command db.test.mapreduce, mention the name of the mapping function as the first argument, mention the name of the reduction function as the second argument, and as I told, out will mention the name of the resultant collection, and query will mention the filter which we want to apply on the parent collection before the MapReduce is getting executed. So we specifically wanted to calculate year-wise total of students for computer branch. So here we have applied a filter for every document. It will be checked that if the branch is comp, only then that document will be considered for applying the MapReduce function. So firstly, from the raw collection that we have, we will be filtering all the documents which are from the computer branch, and then we will be filtering out uh, the specific classes and their corresponding number of students. So let us go ahead and try to execute it on the MongoDB shell. So here we are having, I have already created the test collection. So let me firstly show you the test collection over here. So this is my test collection which we had discussed earlier. Next, what we are interested in doing is we will firstly create our mapping function. So I have a map 1 I'll name that function as map1 function. We have no arguments for this, and there we have a emit method where we want to emit the class, comma, as the class will be emitted as the key, and 1 for each time a class is emitted, a value of 1 will be emitted along with it. Since it is a statement inside a function, we need to have a semicolon. So yeah, it got executed well. So the map. Okay, so now let us go for the reduce function. So we'll go for creating the reduce function. So var reduce 1 is equal to function. Now, as we discussed, it is going to accept the key value pair which is emitted from the mapping function. So let us accept this as uh, year, comma, its count. So if year is unique, then its count will be 1, and if the same key is being sent as year, then it will be accommodated in this count array. And then finally, we are going to sum up the elements of this count array so as we get the total number of students for each year. So here, what the statement we have is return array dot sum of the array count. So what we are going to do here, we are simply going to calculate the sum of the elements of the array count and then finally return it. And there we go. Next, very important, last step is to implement the MapReduce function. For that we have db dot the collection name, which is test in our case, dot MapReduce. So it will have the first argument will be the name of the mapping function, second argument will be the name of the reduce function. Now, instead of creating separate variables like we have created over here, we can simply define or we can simply specify this map function directly as the first argument and the reduce function directly as the second argument. But for proper readability, it's better to define them early and then specify their names in the map reduce function. Third argument, we want a query to be applied. So third argument is a document. In that document, we have many fields and we are interested in using only two of those fields. First is the query and second is the out. Now, let me remind you, there's no specific sequence in which we have to use or we have to define these fields. Since it is a JSON format of document, we can specify any field earlier to the other field. So let us specify the query first. So the query is we have to apply a filter on the branch field of our document. So branch should be comp. This is the query and the output should be stored in some collection which we will call as result. And that's all. There we go. We have input, so it gives a general statistics about the MapReduce function. So what it says, the resultant collection is called whatever collection we got output from this particular MapReduce function, it's called resultant, as we specified the name as resultant. The time it took to compute that collection, and here is a very interesting thing that we had input 5 documents. Yes, we had 5 documents in our collection. We had inserted 5 documents, and 5 documents got emitted. And from the reduce, we are only having, and from the reduce, we had 2 documents reduced. So what this suggests is that there were 2 documents which were having the same key, and that is why they got reduced from the 5 input documents. So the total number of output documents is 3, and rightly so. In our given collection, as you can observe, we had only 3 years, that is BE, SE, and somewhere TE. There's no other fourth year. So definitely there will be 3 unique keys. Okay, so now in order to complete, we will have to check our resultant collection. So db dot resultant dot find. Here we go. If you can see, you have only 2 fields in the resultant collection, and that is what we wanted. We wanted the year to be the key, and that is what we have got. The ID field is the key field, I mean the unique field, and that is why the year values are stored for the ID field. And against that, what we have is a value field, and definitely the value is the total number of students which are in the final year, that is BE, the total number of students which are in second year, the total number of students that are in third year, according to our test collection. So this was a small implementation of the MapReduce function. Try this function out on your own collection. We have a few, let me just take you to another example. Yeah, we have it. So there's another query that we have over here. So I'll quickly show you the collection on which this query can be applied. So we can create a collection called classes, in which there will be documents with fields like class, start date, the array of students who are attending the class, the cost for the attending the class, the professor who is going to teach in that class, the topics which are going to be covered in that class, the books, the ISBN, the title, and the price of the book. All these things will be stored. uh, I mean, it will be an embedded document as a value for this books field. So like this, we have to create many other documents to store in the class collection. And once we have done that, we can find the total cost to attend each professor's classes. So this will be an interesting way. I'll only discuss the solution. You can go ahead and try to implement it with all the concepts that we have learned in this class. So what we are expected to do here, we need to just calculate total cost to attend each professor. So as a part of mapping function, what we are expected to emit out of the map function, definitely the professor's name. So the professor field will be the key. Over here we have, like here, the value for it is Alice Jones. So we'll emit the professor field as key, and we'll emit the cost as the value. So if there is any other course which is taught by Alice Jones, for example, we have here a course which is taught by Alice Jones. So for the first time when Alice Jones is encountered, it's the cost will be added to the array. Second time, whenever we encounter Alice Jones, its cost, the course's cost will be added to the same array. And what we will have to do? In the reduce function, we will have to sum up that array and display the resultant collection. So this is a very simple but interesting example. You can have another query. I have kept it over here. Yeah. So this was the second one that we discussed just now. How many classes does uh, Alice Jones teach? So we'll have to filter like we did it in the earlier example. We'll have to apply a filter over here over the professor's field and then specify Alice Jones as value in that filter. So interesting things we can do with the MapReduce function. Go ahead, try to use your own collections and apply uh, MapReduce function in those collections. So that's it for today. Thank you all.